times. We're checking the sound, hopefully. All right, we're gonna start going in a second. No one is around yet, as far as I can tell. Yes, this is dead space because people should have showed up by now, but I'm just checking to see if anyone is available to actually attend. I'm gonna pause the video for right now because no one has showed up. What questions do you guys have? I'm more than happy to answer any question you have. I even have the assignment 9, the thing that I was just reminding people about. It does not have this one. I'm just to make it hopefully easier for you guys. It doesn't have to compile. It's about trying. Is at least from my perspective. That's what I'm aiming for here. I even have one little change I have to make um, to the instructions that I want to show you, but I think it's house. Grade file, and it says call update grade set. It could be update grade set text. It's an output buffer. It's a text. I have to change in the file that's shared with everybody. But all right, questions. What do you guys want to go over? Do you want to go over malloc? Do you want to go over how to make how to make an array, a dynamic array? What dynamic arrays involved? Do you want to deal with reading in a file? Do you want to what do you guys want to cover? Uh, There is a grand total of 4 people, and no one said anything yet.
I feel like I'm still kind of confused about file input and then putting it into a struct, like kind of like A8 stuff.
Oh, what? Sorry, Danny, are you talking?
Can you hear me?
I can hear you now. Sorry, I was muted.
Oh,
Or
that's
my
okay.
speaker was off.
No, all I said was I was kind of just still confused about like file input and like putting it into a struct, like kind of like assignment 8 stuff.
Right.
Like still kind of confused about that.
Let's. I've already went over part of the solution for assignment 9. So let's. This is assignment 9's function read grade. So we're saying, how do we put all this crap in a struct, for lack of a better term? Okay, so let's have a look at this. So we're going to, instead of using fscanf, fscanf, we're going to use fgetS. That's going to give us the entire line. I actually wrote this function earlier, and I'm just going to reproduce what I was doing before. So that's a great thing to ask. Okay, so what do we need to do? Well, for file reading, there are some things to memorize, but most of the stuff, I don't remember anything. I have a terrible memory. I know it's called file, and even then, I think I looked it up like at the beginning of the term. Grade file, let's call it. All right. I'm going to call f open, and I'm going to use underscore s1 because it's safer. And I don't know what the parameters are. Oh, okay, it's taking a pointer to a pointer. We'll be looking at pointers right now. So in the assignment, in the lecture, so now I can say that that's what that thing is. So since I have a pointer here, I want a pointer to a pointer. The reason it's a pointer to a pointer is because the only way I can change this variable right here by calling another function, the only way that this function could change that variable here is by passing it as a pointer. It's the only way that we have. Okay. And then what are the other parameters in this thing? I need the file name, grade file is the name of the file, and then the reading mode, R, for read. So let's have a look at what this thing says. This says, okay, it's going to try and open it. It can give an error message. That's what error no C is. What does that mean? I got no clue. I also don't care, right? At some point in time, there's some things that knowing where the critical things are, that comes with experience. That's something, unfortunately, there's no avoiding. The where you need to spend the time or where you need to know or where the landmines are, right? If you're playing, trying to think of a good example. Well, video games are classic for this, but I'm not sure if the exact problem. If you're playing Mario, for example, what thing do you need to worry about? You got to worry about the Goomba coming at you or the Koopa coming at you. You don't have to worry about the flowers swaying. You don't have to worry about some of the other things going on in the background. They're distractions. You got to worry what the levels are. You got to worry what the enemies are. You get very, very good. You may not even realize how good you get at figuring out or picking out all the little minutia as you go. And the more you play the game, the better you get at it. So in this case, I don't need to know what this error message thing is until I need to. If I need to figure it out, I'll figure it out. I'll do a Google search for it. This thing is going to open up a file. If I also happen to know that if this thing is not, if this thing here does not work correctly, if the file doesn't open properly, F-grade file is going to be null. I happen to know this from actually looking at examples online as well myself. But so if the grade file does not equal to, and again, since we're getting to pointers right now, or we've already been exposed to pointers a little bit, null is just our fancy term, not even fancy. It's our term that we are using for this pointer is pointing to nothing. If it's pointing to nothing at all, we need some special value. It's null. It's equal to 0. We don't want to use 0 because we don't know, do they mean the number 0? Do they mean that? If you say null, it's for a pointer, only for pointers, and it means it's pointing at nothing. It's like pointing at the ceiling. It's not pointing at any of you, it's pointing at the ceiling. Null. Okay. Otherwise, if it is actually equal to null, then I got some problems. And so I could say something like printf, the file was not found. All right, and then my file name, so grade file. Okay, that's reading the file. And then what I want to do, I'm going to read in each line, one after another. Then I'm going to close it. Okay. I find this might help me, may help you as well. I want my plan of attack. It doesn't hurt. I can leave it as a comment. I'm reading the line, close the file. There you go. I know what I'm planning on doing. Each line. So I'm going to keep on calling fgetS. Let's see what fgetS gives us. And then it's going to say, oh, I'm going to need a character array. I'm going to need something to store that line of text in. So I'm going to do something here. Let's do this. I need a character array. Character array buffer, right? It's going to store. This is just a big old array of characters. Holds 200. So that's where the message is going to go into. I need to find out how many characters I have. It's 200. I can store up to 200. And I need what the file thing is. This thing here. So I'm going to read From the grade file, I'm going to read a full line of text, store it into a buffer. That's what this is telling me. Read in a line of text, put it into a buffer. That's it. Let's see what the output of this, let's look at my function again. It also has a return statement, that first character pointer thing, char star, then that underscore, right? That char star means fgetS returns a character pointer. And the only reason I care about that is I need to know when I'm at the end of my file. So if I take my grades, for example, I should read in this entire line of text that'll go into a buffer. I'll call fgetS again. It'll read in that entire singular line of text, put into a buffer. If I called it again, put into this one, put into a buffer. I'll read in this line, put into a buffer. This one, a buffer. This one, a buffer. And then if I call fgetS again, the seventh time, 1, 2, 3, 4, 5, 6. If I call fgetS a seventh time, what happens? I can't, there's no text. I'm at the end of the file. I need some way of saying that I'm at the end of the file. That's what that return value is for. I'm going to assume, I could be wrong, I'm going to assume that when I get to the end of my file, so there's no more text to read in, fgetS is going to return null. It's my safe term for, hey, something bad happened, or hey, I'm not pointing at anything, or hey, nothing went into this thing. That's sort of what you can expect for convention. If something is gonzo or bonkers or not broken or anything like that, null is a nice safe value to return. Sometimes it's not going to be null, but oftentimes it is. So I'm going to, here's my fgetS. This would return the first line. If I called it another time, it returns the second line, then the third line, then the fourth line. Well, what I could do is say this, while does not equal to null, I'm going to print f, just line of text. I'm just going to see that this thing is all working. And then I'm going to have this. Okay, and a buff. So all I'm doing is I'm reading line by line, throwing into the a buff. I'm going to print off line. That's not what the answer is. I just want to see it all, make sure it's working, right? I don't want to write all my code and then find out I did something wrong. Even if it compiles, I don't know if it's going to work. So I want to do a little bit, test it, make sure. This is going to test to make sure I'm reading in the file right. I'm also going to be paranoid, so bear with me here. Loop 10 or num lines. Oh, num line. Okay. And okay, 30. What I might want to do is, okay, that's not. Parentheses around this. Parentheses around this. Just paranoid. What I might want to have is, if I'm not 100% sure that this thing is going to not go off to infinity, go an infinite number of times. If this doesn't return null, let's say it returns -1 or something, where the original pointer or something, say it doesn't return null. What's going to happen? Bad things are going to happen, right? This is going to go off to infinity. If it's never equal to null, it's going to keep looping. And I got an infinite loop, and there's nothing I can do about it. And I have to stop my program in a hard way. It's going to be very hard to deal with. So I like being a little paranoid. I'll put a little counter in there just to make sure that this is going to actually stop. So if it ever gets up to 30, stop, because I know I don't have 30 lines in here. Okay, why is that while loop yelling at me? Let's have a look. Missing semicolon line above. There you go. Okay. And then I said I wanted to close the file. So I'll finish that one last part off here. F close, the name of my functions. I figured it out with let the autocomplete do it for me. Grade file. Close the file. Let's see it in action. Let's not assume that it's going to work. Let's test. I may have bugs or errors somewhere else. Hey, it actually compiled. Good. Go us. Sanity check. That's a great question, Danny. So I want to make sure that if this thing, let's say fgetS never returns null. Let's say, just for argument's sake, it returns some other pointer. It returns my original pointer or something like that. Or it always returns the pointer to a buff. It doesn't do what I think it does. Then I want to make sure I don't have an infinite loop here. I'm going to get rid of that the moment I know my code works. This is me, how I think through my problems when I program something. Is I'm not sure what this function does. Let's test it out, but I want to make sure that this is not going to go off to infinity. If that loop goes off to does it an infinite number of times, it never stops, it's going to be problematic for me to stop my program. I don't want that. So I just have a sanity check. I could also have just an assert that blows up if it gets to 30 to stop my program. That would have also been fine. Or I could have left it all the way out. It's going to work, but this is how I think through things. All right, let's see what I have here. Line 1, line, another line, another line, another line, another line. I get to the last line, I stop. I clearly did not do 30 lines in here. Okay, so I know that this stops when it returns null. That's actually what's stopping this thing. I can deduce that it's not my number of lines less than 30 that's stopping this thing. The only thing that's stopping this thing is fgetS must be returning null when I get to the end of my file. All right, I can get rid of that num lines thing. So let's get rid of that. Let's get rid of, there we go. And all right, let's do one more thing though. We have this, okay. It's not gonna be printf though. We're actually gonna call another function. In fact, I even tell you what the function should be, but I think I left off the word text at the back of it here. I wanna call update grade set and text. It's gonna take a line of text and update my grades, or at least for assignment 9. The grades, this return value here, this grade set 1400 in assignment 9 is every single possible number you could possibly want for all of your grades. So I set them all to safe values. That's what I'm doing here. Setting them all to safe values, like sanity safe values, right? And then for every line of code that I read in, I'm going to update what's being stored in that data, in that structure. It's a giant structure. Notice the weird thing that we have though. I'm asking you to pass in a pointer to that structure. Why? Because I want to change that particular structure. Sorry, I pass in the actual structure, a pointer to that actual structure, and then I can modify that actual structure as I go. That's one of the benefits or one of the quirky things about pointers. I'm saying where this structure is located in memory. That's what I'm passing in. And then I can go into that structure in another function and modify it. That's for the assignment, not for what the original question was. But okay, so the name of the function call, oh, didn't need that extra line. Okay. Update grade set text. I'm going to take in a pointer to the ret val. And what's the name of my buffer? It's a buff. All right. Could be a out buffer, whatever you wanted to call this thing. Okay. This is going to call this other function line by line for every line, and I'll update this thing each time. Let's jump to that function. Because this is actually doing what we were trying to show, which is I have a line of text, and I'm going to deal with each part individually. This is what assignment 8 had you guys do. So here we go. In fact, I probably should have warned, that was a loophole in my system. Assignment 8, if you happen to be really good at reading code, you could have read assignment 9 and figured out what to do for assignment 8. But I have figured out the number of fields. That's what this thing does on that line. So let me have a look at the text line. Here we go. If this is our line, how many fields do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Num fields is going to be 16 in this case. This is a function I gave you guys so you wouldn't have to do this yourself. It was an attempt at making things easier. All right. On the first line, it's equal to 16. The next time I call the function with another line, the next line of my text file, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The time after that, it's going to be 2, 2, 2, 2. That's what get num fields gives you. All right. So it's going to be 16 the first time, then 12, then 2, 2, 2, 2, 2. So as long as the number, I'm doing some little sanity checks to make sure the number of fields is, well, the number of fields really has to be greater than 1, right? If I just have, and the output buffer, this is just a line, this is the line of text that you had. It could be this thing here that's highlighted. It's just text. It's the line from the file that I was using. And I called it out buffer just so you would compare the two of them or see the two of them together. But this is just a line of text, like quizzes and then a bunch of quizzes afterwards. Oh, but notice that's a great question, Jeanette, because everyone goes through this. Let's try it with a different way. Let's go back to what function, let's go back to what that was called. There we go. Grade file. Where is that made? Notice read grade file has a variable called grade file. Was that word or was that variable grade file anywhere else? Actually, no, it's not. The thing that's originally calling this is just a string. What happens? I make a brand new variable called grade file, and I set it to the value being passed in. The value being passed in is effectively this array, the location where that text is. I pass values into a function. Let's look at, so when I call read grade file, the value, the location where this text is passed in. So I make a brand new variable that doesn't exist, but didn't exist before. When I call that function, I make a brand new variable called grade file, and I set the value based off of the thing calling my function. In this case, the location where the file name text is. With me so far. So brand new variable, and I set the value. Let's go to this thing. So two values are going to be passed in. Go to the definition. I'm going to go to the definition. This is a brand new variable, and the value is set. This is a brand new variable, and the value is set. That's I could have called this Susan, doesn't matter. It's a brand new variable, and the value for it is set. I don't pass, the variable is not the same. You can have a variable, two variables with the exact same name, and the way you distinguish it is which function am I in? There are multiple people named David in the department. Which one is it? The one teaching 1400? Oh, that's David Sprague, right? That's how you could tell the difference. There were, at one point in time, there were 3 Chris's in our department. Which Chris? Were they fixing your computer? Yes, probably. Oh, okay, well, that's one Chris, right? Was he complaining about the logistics of all the course stuff? Then that was Chris Jocelyn, right? Chris Clark fixes the computers. Chris Jocelyn is the director of the school. You can tell based on the context. So brand new variable named a out buffer that has the exact same value as a buff. Great point. That's how functions have been working this entire time. It takes sometimes multiple exposures to realize it. So brand new variable has that value. Okay, so what am I going to do here? I'm going to get the number of fields from that string of text. And then I'm going to get the very first field. That would be, let's look at it again, quiz. Okay, and then the other fields are all numbers, right? So I get the very first field. That is the what type of grade it is, the grade name, if you will. And then I'm going to, wait, how many fields? And then I'm going to make a dynamic array. We'll talk about that in a second, but this is making an array. And then for each of the other fields, so I've got field 0, field 1, 2, 3, all the way up to 15. I am going to get the field, put it into some kind of buffer. This is just some array. And I'm going to convert that to a number and store the number. So I am going to, this is going to get we can actually put a breakpoint in here. Let's see what this does for the breakpoint. What probably look better. Okay, and what other things do I want to point out first? I'm going to run the code one more time just to show this in action, but let's have a look at this thing. What does this malloc thing do? That's what this week is all about. We didn't need it for A8, but it's good to talk about. It's also for the code that has to compile. What does malloc do? It's going to make dynamic memory. As in, I don't know how big this thing is. You could give me any text file. I have no clue how many fields I need here. But malloc allows me to, they're not all going to be the same size. So malloc says, give me this many bytes of data. Yes, it is as insane as the raw number of bytes of data. Okay, and then I'm going to say it's actually an array of integers. So how much do I need here? At 15 fields, so there's 16 fields in total, minus 1 because the first one is not a number, it's quizzes. That gives me 15 fields left over. 15 fields multiplies by the size of an integer, which is 4 bytes. 15 times 4 is 60. This is asking for 60 bytes of data from the computer. So 60 bytes. And then I'm going to say, oh, by the way, it's an array of integers. So there's actually only 15 numbers in here. That's what's going on here. I'm getting an array of size 15 here, or 60 bytes of data. Then, that's why I need to use a size of operator, by the way. Then I'm just going to fill in each of the numbers into each of these fields. So field 0, 1, 2, 3, all the way up to 14. It's going to be including up to 14. 15 numbers in total. So that's what this thing is doing. It's getting a line of text, a snippet of text, converting that to a number, storing that number in my array. Okay. Let's see this in action. What the heck? All right. Right. Boom. Hit a breakpoint. What do we have here? We have a out buffer. It's this big monstrous thing here. Quiz 100, 100, 100, blah, 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 all the way down. That's what this line of text is. That's what a buffer is. It's that full line of text. I'm going to get field number 1. So 0, 1. It should be the value 100. Number buffer is going to store some value. So let's move on to the next line. It's going to get the field 100, get 100 and put that into numbuff. Let's look at what numbuff says. Okay, progress. Okay, there we go. It's 100, but it's not the number 100. It's 100. It's the text 100. It's not a number. That is the character 1, the character 0, the character 0. And then a 0 at the, and then a /0 at the end. It's text, not the same as a number. It's like writing out 44 in cursive versus using the number 44. One is text. So even if I'm putting numbers. It's not the same as an actual number. That's confusing for a lot of people. So I have the text, I have a string 100. That is not the same as an integer 100. That is 3 characters in a row strung together, or actually 4. Include the magic ninja terminating character. A2I takes this text of 100 and converts it to an integer. So A grades at position I equal to 1. So at position 0, A grades at position 0 is going to be should be equal to 100 when I'm done with this. Next line. The first number that it has in here is 100. Then I'm going to store the next number. Then I'm going to store the next number. Okay. With me so far, hopefully. When I'm done with this, I'm going to have an array full of numbers. And I'm going to have an array full of numbers, and I'm going to have the name of the field, which is then going to be calling rate the grades. A2I, ASCII to integer. A2F is ASCII to float. And yes, they got really lazy when it came to all these naming things, and you just unfortunately figure it out. Actually, you have to you normally Google it, right? How do I convert an ASCII string or character string to an integer? And people will say, oh, it's A2I. You just do it. That I said that was the name of the command in assignment 8, I do believe. So I've read in an array of integers. I got all my integers. I have what kind of name it is. Right now it's quiz. I got an array of integers. And how many fields do I have? Well, it's going to be, there's 16 fields in total, so this is going to be 15. So if I have an array of size 15. I have the array full of numbers. I'm going to have the array full of numbers, and I'm going to have the name of the grade type. And what this thing here is going to be doing, and we'll jump to that next. Okay, and we're going to jump down here. I'm going to jump into my function. So I'm going to go from create grades. I'm going to jump into the function. Here is the name of the field, quiz. Here is the array of grades that I'm going to be dealing with. I'm only seeing the very first one, but there's a whole array of values in here. And how many grades I'm dealing with? 15. And so if quiz text quiz, right, that's just a constant that I've declared at the top. If that's equal to, or it's a substring of the original thing that I have here, but if they're equal to each other essentially, then I'm dealing with quizzes. Otherwise, I'm dealing with strings or assignments, or otherwise I'm dealing with some other thing. What do I have here? I have this data structure. If I had a data structure like in assignment 8, I can look into the actual values in the data structure. So let's look at that. This is going to give me a data structure. So if I type in things, I don't have to remember what the heck the values are. Return value dot. Okay, I have an array. Great. I have the grade type. Great. I have the number of grades in total. Okay. Remember, I'm trying to set this. So I'm going to create one of these B grade 1400s. I have to set the values here. I've set the grade type to type quizzes. I set the number to keep the number of grades counted. And I've set the percentage grades value to quiz percent. I could also, yeah, let me put it to what I did earlier today. One other student. Ret val dot a grades is equal to a grade. This thing here is going to go into my data structure. And number of grades that I have is equal to that. How many grades I'm going to store? That's what I want in the end of the day is this data structure is going to have everything I need to calculate the grade for, let's say, assignments or for quizzes. So you pass me one of these D grade 1400s that has all the information I need for an assignment, and I can tell you exactly how many points in your total grade should be like. So if you have, let me see, let's say you have 100% on all your assignments, very optimistic. You have 100% on all of your assignments. If you have, and the assignments are worth 30%. If I pass in this data structure, it has everything I need and it'll spit out the number 30, as in that's how many points contributing to your final grade are from the assignments. All your assignments were 100%. We dropped the right number of assignments. They're worth 30% in total. All of those numbers put together, when you do the calculation, you should get 30. If you get 50% on all your assignments when the average is finally calculated, it would be the total grade for the assignments is 15 points. You add up all those points together, you'll get your final grade in the course. Is that defined somewhere else? Yes. I missed a couple of minutes. So yep, it's not. That is perfectly a great question to ask. So what is this? Well, we can actually go to it, or we can hover over it and be lazy. Wait, okay. So quiz text. Well, maybe we can look for a quiz text. Let's see if it's in here somewhere. Well, we're just going to do a search. Okay, there we go. Why am I doing that? Well, if the file that I'm using changes the names, I don't want to have to change my code, or I don't want to change my code everywhere. I want to have it. Maybe it's called Super Quiz 5000. Well, instead of the word quiz here, it would be Super Quiz 5000. I'd have to write Super Quiz 5000 everywhere. I just want it as a constant somewhere so I can refer to it over and over again. That I don't, if I write the word quiz in quotes every single time, what's going to happen? What if I accidentally call it quiz 2, quizzes? If I don't use a constant, if I use the actual text everywhere, if I make a stupid spelling mistake, let's instead of final exam, it's final underscore exam everywhere. It's going to not find the thing I'm looking for because I have made a little typo somewhere. I don't want that. What I want is if you make a stupid little typo while typing something up, it tells you there's an error and it yells at you, not, oh, okay, I'll take it. If I put in final exam with an underscore in here, it's not going to yell at me for it. So let's final text. Let's go back to, okay, let's do an example of it. Okay. If str. This is, I'm using substring to make my life easier. I'm hoping you could use string compare. That would be perfectly fine. Okay. So if whatever final text is, it's I think final exam. If that is a substring of this thing, or if they're the same, essentially, if they're the same strings, I'll go into this case. Otherwise, I'm going to miss it. Okay, let's try. Instead of this, oh, there you go. Looks right. Seems right. Looks like a nice name for the string. I'm relying on my memory that that it was called this. What if it's not called that? It's actually not called that. And yet it is just going to bypass this thing. It's never actually going to go into this condition because I named it wrong. But it's a string. It doesn't know that I named it wrong. It's not smart. Because I'm just using a straight up string here instead of a variable. If I spell it wrong, if I have a little typo in there, it's going to bypass this condition and you're going to spend days trying to figure out why the heck it keeps on missing that condition. Ideally, what I want to do, this is just safety sanity checks for yourself. If I put this in, and let's say I put in, let's try it this way. It yells at me. If it's supposed to be a variable and I have it defined somewhere, I use the variable name and then I make sure that I don't accidentally spell something wrong. Oh, it's supposed to be this. Oh, that makes it all work. Notice what I was doing earlier. I put this chunk up here. Sorry, this chunk up here. Why? Because every single one of these conditions, every single the quizzes, the assignments, all of these things, they're all going to store these same A grades and num grades in the structure, no matter what. So I might as well move those on the line above. So there. Same for all conditions, right? And then maybe what I want to do here, so this is for the final exam. So if I'm dealing with the final exam, what are my values? It's going to be type underscore final. I have to look into what this thing is. I gotta look at that variable. Type final exam. I just predefined things here. Type final exam. Okay. The number to keep is going to, I don't know if I have a variable for that. I'm not sure I have a variable for this one. I might. Lab grades counted, quiz grades counted, final grade exam percent. I'm going to need that one. There's only one final exam, so I'm going to put it just at 1. That one is definitely not going to be changing. Okay, and here we go. Never keeping 1. Not that. There you go. And here's the percentage for my final exam. So what I could do is for every single type of data that I have, I'm just setting, I have the array, I have the grades, and I'm just shoving them into this structure. I have this structure that I'm making, this D grades 1400, which has a whole bunch of data in it. And I'm just saying, okay, the array is going to be pointing to the same thing as this array here. The number of grades is going to be set to number of grades. The grade type is going to be set here. I'm just using the struct. If you want, you guys need to see what the struct looks like, or have you looked at this? The struct is up at the top. There you go. Here's the grade type, the array of grades that I have, the number of grades or the size of that array, the number of grades that we're keeping, and the percentage of the grades that it's worth in the total. And if I put one of these things for every single type of assignment in grade set 1400, it means I have all the data that I could possibly need to figure out my final grade, all in one structure. That one structure, grade set 1400, has everything. I pass that into something, I can just calculate my final grade, and I'm done. So this contains everything. This contains everything you need for calculating one of your grade parts, like the quizzes, like the assignments. I'm not sure if I'm answering your question correctly about using a struct and reading in from the file. So we read in from the file. I pulled off each individual field from the file, one after the other. I even converted some of those numbers, most of those numbers, to a number. Even converted most of those fields to a number. There you go. There you go. So I converted each of those fields to a number, stored it in an array. Then I can set my structure based off of that array. The idea is I didn't want to be doing it live with the text. I don't want to have a text file that I'm reading in and then doing the calculation as I go. I want to sort of save everything up and then do it properly later. I want a more general solution if I can. So this thing takes in, reads in each line, converts the number, converts this into this, the data to this kind of format, this format right here. And then if I pass this off to somewhere else, I can convert my data structure. I can calculate my grade. I have one other thing that there was a change that I made. Grade D grades, update grade set. This is the change I made. Because I don't think this function name was very very clear when I wrote it first. So I've updated the files you had online if you wanted to look at it. But this is essentially what you're going to see. If it is a quiz type of quiz grades, I set the value, the thing that P2mod is going to have for the quizzes, I just set it to data structure. So if you pass me in assignments, let's do another one of these. Case type assignment. This is the big data structure that has everything in it. I passed a pointer to it so I can modify that data structure directly. But that doesn't mean I have to use this little arrow thing. But I passed this thing in, and this is going to be modified. I know it's going to be modified. I passed it in a pointer to it. What is the arrow symbol after the pointer? Great question. It is exactly the same in case, actually, you can actually even do this. Dot. Okay, let's do that. Assignments. And it auto fixed it. It is the dot if you're using a pointer. Instead of what normally with a struct, we put a dot and it gets the next, it tells you which fields you have available. The arrow is the same thing if I have a pointer. It says, go into that data structure, go into where that pointer is pointing, go to the pointee. So I'm at a pointer, go to the pointee, and now modify go and tell me what the fields are, or go to that particular field. So it's effectively the same as a dot, but only for pointer, but it works for pointers. If that makes sense. You'll see that a lot in 2400. That's why I want to make sure you get exposure to it. Okay, and I can say that it's equal to grades. If it's quizzes, I'm setting the quizzes field or the quizzes part of this data structure. If it's an assignment, I set the assignments part of the data structure. I'm just going to assign it to different things, and I'm done. If I do all of those for the different types of data that I have, so final exam, exam one, exam two, labs, I think is the other ones, then I'm done. I'm just putting this B-grade 1400 into the data structure. Now, you might say, well, why don't we just pass in the P2mod data structure and return a grade set 1400? And yeah, you could have done that too. That's perfectly fine. The difference is I just wanted to show how you can use pointers to modify variables. All right. Can I unpack something else? Do you want to look at malloc? We could do like a character array with malloc or something like that. All right, let's do this. All right, so I want to make let's make void. I'm just making a pointer, a function. It's just going to do so. I just want to move it out of the way that I can delete it later, not have to worry about changing stuff. Okay, malloc fun. It's always fun with malloc. We're going to do what? So what we're going to do here? Let's see what we have. Make char array. Put in the array. Right. Contents of the array. Read the array. That's what we're going to do. So essentially the assignment, but with characters. So very different. Oh, very different. So what do I want to do? Let's also, do we want to use scanf? I'm not going to use scanf just because it's going to complicate things, going to muddy the waters. All right, let's do this. I'm making a character array. Give me, you can ask for a size from the user if you want. Let's do that. Printf. Scanf. Okay, I'm going to have set to 10 to start, just for just for something here. Our usual suspects. In fact, though, we saw this before. And I said you had to take it on faith why that's the case. And why do we need to put that and in front? We didn't have to do that with strings. We had to do that with integers or floats or any value that we had that was just some kind of number like this. And the reason is that I cannot change array size directly unless I pass in a pointer. If I pass in it as a pointer, scanf can stomp on the value and change from 10 to 20 or whatever value it is. If I pass it in as a pointer, I can't do squat if I just pass it in as a variable. If I pass it in as a variable, it's going to make a copy of that. It's going to make a brand new variable, set that value to a copy of whatever array size was, and then destroy the variable when I was done. So I need to pass it in as a pointer to it, that variable. Okay. While it's less than 2, just do it a bunch of times. If you give me some garbage value, I'm going to keep on asking. I could also have done it as a do while loop. That would have also been fine. All right, that's just me getting the numbers. I haven't even done anything new. Let's actually set up malloc. So I'm going to have a character. If I can type, wow, I missed the keyboard. Here we go. Char. Also, caps lock is on. Char. Let's call it a text. Okay, it's my text array. That's what the A underscore is for. Just, hey, it's an array. It's not just a pointer. Okay, my malloc does what? It asks for how much memory I need, and then what I'm going to do is cast it to the kind of data that I want. So here's me casting to the kind of data that I want. Malloc's going to return a void pointer. It's just going to be a pointer. I don't know what kind of pointer it is, just some pointer, someplace in memory. So I always cast it. All right. That's the size of my array. But I also need to know the size of a character, because this is how many bytes of memory I want. Notice a character is 1 byte of memory, but I still put it in there. Just put it in there always, whether it's character, an integer, whatever the case is, make sure you call that size of, because if you forget it, it's assuming 1. If I have an array of integers, let's say I have an array of 10 integers that I want, I will get 10 bytes, which is not enough to store 10 integers, and bad stuff will happen. It's just good habit. Always include the size of. This is how much each of these units is. Each part is 1 byte in this case. Multiplied by how many of these I want. That's how many bytes of information I want from the system. That's what I'm pointing to. This is pointing to the front of a chunk of memory that I'm being given from the system. Okay. If a text, let's do it this way. Remember, we have a sanity check. If things go bad, if things go really sideways, it's going to return null. If I don't have enough memory to store, like if you give me some ridiculous number, we can do the error check as well. Array size is greater than 10,000. If you give me something ridiculously large as well, maybe I can't, if you give me like 10 gigs, you're asking for 10 gigs of characters. Malloc may not work. It might return null. You don't have enough memory to allocate. And then you need to be able to handle that case. That's why we have this little test at the end. We get the memory, but if things go bad, it's going to be equal to null and just get out, right? Assertion failure of, return from the function, whatever the case is. Okay, this is going to make, but we're going to put it inside the if statement. Most vast majority of time, you don't have that you never have a problem of getting the memory, but okay. I'm going to put some random string in here. I'm going to make up something here into this character array. So strcp string cpy underscore s. This is me copying the string. The destination is a text, just like every other character array we've ever had. The size of the array is should be array size. That's the maximum I can put in there. And the thing I'm going to put in there, hello world. All right. Yeah, because. Now, notice we will get an error. If you say the array size is size 2, it's allowed. And I try to put hello world in there, what happens? It blows up. What it's going to do, but that's fine. So that's what's going to happen if you try and if I make this array way too small, it's going to blow up. Should even blow up with just size 10, but let's see. 2, 3. That's 12 characters. Let's make that 12. I'm going to start it off with some safe value. We're going to make it 10 or something. So I've just copied a character string over. It works exactly like my other arrays did. They are identical to one another. I'm going to print off the contents. So print f the array text, same as before. Just testing my code. Notice I might need to keep around how big this array is, because if it's an array of integers, there's nothing about this that tells me how big this thing is. I can't use size of size. It doesn't work for this. Size of would tell me the size of a pointer, not how big the array is. This thing is just a chunk of memory that I'm pointing to. I have no idea how big that thing is. I have no way of knowing how big that thing is. So I need to pass around the size of my array, except with character strings. With a character string, when I get to a 0 at the end, I know I'm at the end of my string. All right. And then one last thing, I'm going to free my array. Why? Because I'm done with it. And if I don't free it, I still hold access to it. If I don't free it here, I still control that however many bytes of memory that thing is. And I have nothing pointed to that byte of memory. So I keep on using that analogy, but I take a book from the library, I take out a book from the library, and then I lose the library book, or they lose access to it. What blockbuster? Let me see. So it's mine. Yeah, sure. I take a book from the library, I lose it. I still gotta owe that book back to the library, but I don't have any access to it. If I lost it, if I moved somewhere else and I don't have that book anymore, it's still mine. I still owe the book back to the library, but I've lost the reference to it. I don't point to it. I don't know where it's located anymore. If I don't free it and I get rid of this pointer, a text, defined right here, it's defined right here. At the end of this function, this goes back to this pointer, the location goes back to the system, but the memory is still mine. I still own the memory. I just don't have any reference to it. And that's called a memory leak. Those are bad, bad things. So why other languages don't allow you to do this, actually. I gotta go do a reference to this malloc fun. Okay, I should use that's. And do we have the maximum size here? That's the last parameter, I guess. I don't need it for that. It's an integer. I don't need it for that because it's an integer. All right. I need to go to my main memory and I'm going to call malloc fun. All right. All right. Let's see this in action. Oh, what's the problem? Well, I say I have a function called malloc fun. It's defined later. So let me just find my functions. I'll hear all my prototypes. I'm going to include malloc fun. Okay. Void fun. There you go. That way the main method knows about this function. It's defined below the main method. It doesn't, it just goes top to bottom. All right, it's working. Let's see this in action. All right, please give a size of the character array. Give me a number, a reasonable number, please. 8. Oh, we're gonna have a problem with 8, but let's find out. Let's see it. Great. Boom. Should have blown up nicely. What happened there? Well, even show me where it is. Array size is 8. Great. Here's my array. Great. This thing is way too long. It blew up because it's not long enough. Okay, let's try it again. We should have given better instructions today. Please give it a size of the array at least size 13. All right, and I'm going to check to say if it's less than 14, or if it's greater than 1,000. Repeat and keep on asking. All right. Because there wasn't enough space to hold hello world in there. All right, let's roll it again. All right, give me a number that's at least size 13. I should be actually at least size 14. 20, there you go. The array has text hello world. Done, great. Should say at least size 14. So the array has outputs. The array has text hello world. Here's my hello world. We're good to go, and then we return. It worked exactly as I expected it to. And then I free the array, and I'm done. Let's do one other thing here. Oh, I need to continue. Add a breakpoint somewhere. Let's do one more thing. I'm intentionally missing something here. Now, let's see this in action. It might yell at me. I'm hoping it doesn't, but it might. Oh, that's the worst of all worlds. Here we go. Okay, so I freed my memory, and now I'm outputting a message. So let's try this, and it might work. I don't know what's going to actually happen here. So let's put the 20 in again, just because we know that number is going to work. I'm surprised it actually does that. Here is the new message, which is it's gibberish. Why? Actually, I'll wait for a second. Why is it gibberish? And then I'm going to do. Why is it gibberish? Why did it give me a bunch of gobbledygook afterwards when I tried to print it out again? Oh, wait. And you can also guess or just say, I don't know, but that's fine. There we go. And the even worse situation. Now it's not gibberish anymore, but it's worse. So all I've done now is instead of a debug build, I did what's called a release build. We're not ever touching release builds because they're too dangerous. But a release build means it optimizes your code as much as humanly possible So it doesn't give you anything safe, doesn't error check, doesn't safety check, doesn't do squat, including what we're just observed. But we'll see what. So why is it that I got gibberish beforehand? Before I didn't have hello world, hello world. I had hello world and my printf statement right here. And when I do the printf right here, I get gibberish. I get blah, blah, blah. There we go. Thank you. Yeah, well, I freed the memory. So I gave it back to the system. Notice what I said. And so the debug build clears it up afterwards, right? So that, you're giving it back to the system, you're sort of sanitizing your data. What happens in the release build is it's more efficient, as in it doesn't do any sanity checking, it doesn't do any error checking, it doesn't give you default values for anything. It is whatever was in there to begin with. So I had an access to the array, I gave it back to the system. I still point to that memory. And so when I do a printout statement of the memory, which is no longer mine, I've given it back, I still have access to the original memory. I'm pointing to this memory. It could be used by some other process. It could be used by something else. It could be used any other way. And I'm still pointing to it. The memory stomp, as in I can change something that's not my memory anymore, which is worse because it means I can modify if somebody else gets that array. Let's say make an array, give it back to the system, make a new array, which is pointing to the same chunk of memory. It's just memory. We're using that chunk of memory again. But my original pointers to it, I could have two different processes all modifying the exact same chunk of memory without me knowing it. Good luck finding that bug. It is brutally hard to find bugs like that. I spent literally days trying to find bugs like that, just because it's so easy to miss something. You go like one byte over the edge and you're stomping on something else. If you don't make sure it points to nothing, you got a bad time. So if you've given back that memory, you cannot use it anymore. So what I want to do, instead of having a gibberish, I want to say a text is equal to null, as in I'm not pointing to anything anymore. I freed it. I want to set it to null so that when I try and print something out, either it blows up or it gives me null or it does something. I have to always check out what printf does, but I want it to make sure that I don't accidentally start stomping on memory. It comes up in weird ways. So this is still the release build. Okay, we're gonna make size 20. I'll move this over. And now it outputs null because it says it's null. And printf is nice enough to have some kind of way of handling null. But it makes sure that I know that I've accidentally looked at the wrong thing. That's what I ideally want. So let's really go back to debug build. I want to make sure that when I'm done with my memory, whenever I call malloc, I set that thing to null. Because if I don't know what I'm going to do with it later. That's one of the big things. You free it, you set it to null, just to make sure. It's a sanity check, right? I'm trying to think of a good metaphor in this case, right? If I'm done with something, I want to make sure I don't have access to it again. If you leave your apartment, they want all the keys back. You're not allowed to keep the keys because they don't want you walking back in that apartment later. They want to make sure that that person's house or that person's apartment is their apartment, not yours anymore. If you made a copy of their key and kept it, you have access to their apartment now, even if you've moved out. And no one wants that. That's just creepy. Don't be creepy. Right? That's what we're doing here. Make sure you have no keys to the apartment. We freed it. You've given up the apartment. You give back your keys. All right. Other questions, queries, concerns? That's malloc. Okay, that's what you'd be doing for the assignment. You've already done the average of a bunch of numbers. It works the exact same way. Look, this thing is working exactly the same way as what our static character arrays beforehand. Nothing has changed. In fact, let's do one more in here. Let's do, let me see here. Where is it now? By the way, this is what we're doing here. The grade data, I'm going to call free grade set. And then I need to fix this piece of code because I'm just calling free on A grades. Should I just call free on A grades multiple times? What happens if I call it more than once? Okay. Bad things happen. Don't call free multiple times. Make sure it's null so that you can catch the error. Updating the struct again. Okay, so what do you mean by updating the struct? We're setting the struct values. Is there something, I'm just trying to figure out where the concern is, like how to access things in a struct? Okay, retval. Oh, unfortunately use the word retval all the time. Okay, I'll jump to that. I was going to make a dynamic array here, but that doesn't matter. Let's do a quick dynamic array. Here we go. Sure. Okay, assert, make sure it works. Close, and then after I'm all done with this, Bob. Done. Same thing, nothing's changed. One's a dynamic array, one's not. Okay. Let's look at there are a bunch of things called retval, but okay, there we go. This thing right here. So this is a struct, right? When I make one of these, when I call this, it's going to make a struct with a whole bunch of data in it. As soon as I say that, I'm making an instance of a struct that has all this data in it. If I actually go up to it and I go retval dot grade type, I can just set the grade type. If you want, I can look at grade set 1400. Is that the pointer to it? There's two different things here, but this is a grade type. So just a bunch of data, and I can just set the individual value. So grade type is equal to this, just a number. Number that I'm keeping, I can set the value. Since all these values are coming in, these are constants that I've predefined somewhere else. This is the array. So the pointer to the array, the pointer to an array is going to be set to the pointer to this array. They're matching the pointers. So this is the pointer to an array here. It's just the pointer. It's just a pointer, but I'm saying it's an array. Is going to be equal to this pointer. The number of grades I have stored in this data structure is going to be equal to this number. In the terms of the grade set, this thing here, what do? I have a bunch of grade information. It's just the data structure. And I'm saying go into this particular structure, find the quizzes field in that particular structure, set that quizzes field equal to whatever this thing is. Just copy all the data over into this other thing. So this will, if I pass in a quizzes data structure, it will change this thing. It will change what's stored in the quizzes field for this data structure, grade set 1400. If I have an assignment data structure, it'll set the assignments field in this data structure. And I'll just keep on doing that a bunch of times. So what I really want is for update set, update to grade set text. All right, I'm creating the data structure based on the line of text. Then I'm just updating my my overall data structure. Is it this part that's the confusing part? Maybe the fact I don't see faces. It's really hard to gauge a room. I'm sorry. So this thing in total, it has a pointer to a data structure. I then make one of these types of data structures, a D grades 1400. It has all the information I need to calculate the marks for like an assignment or for a quiz or one of these types of data. It's all one-stop shopping. It's all the data I need for that to calculate what your assignment grade is, for example. And then I just say, okay, change one of the interior fields to this thing based on this. Copy it over. Not, I think I'm not understanding what the question is. So here's my data structure. This has everything I need to calculate one of my types. So it could be exams, it could be assignments, it could be anything. And this has all the grades about quizzes, all the grades about assignments, all the things I need for calculate the grade for exam 1, or exam 2, or the final exam for the labs. Oh, okay. So it's more, you got to figure out the field that it's being called. If you want, we can change the names of all of those variables, and you're free to do so as well. You can change the names to all so that they're all consistent across the board. But just be aware that they're different variables. I make a brand new variable and I set the value equal to whatever called it. We do have a lot of parts, but so if I only had, and I think next time, next time I teach the class, maybe in the fall, I might just do the one line, not a whole bunch of lines, and just do the quiz grade. That's it. The idea is I could read in all the data for that one line, and because I have all the different parts, I have one data structure that stores everything, and in that data structure, I have another data structure. So I read in a bunch of numbers, I update the information for that one grade type, and then I put it in the bigger bucket of different grades being stored. So the text being read in and stored. Let's have a look at this. And again, your code does not have to compile for this part of the assignment. If you just try your best on this. So here is the file I'm reading in. I'm going to read in a single line of text at a time. So it could be this. And now I do not want to worry about all the other stuff. I want to worry about that one line of text and how I deal with it. And then I'll worry about this one line of text and how to deal with it. So I get the single line of text and then I update all the stuff about my grades based on that one line of text. Nothing else is going to change, just that one line of text is going to modify one of my data types, like quizzes or assignments or something like that. So that one line of text defines all the grades I need to know about for quizzes or assignments or whatever the case is. I then call this function, so I'm going to jump to that function, and here's the line of text I have. Here's the thing I'm going to be modifying. And I'm going to get all the fields, all the data for that line of text. So I get the number of fields. I get the first field to say what kind of data type it is, quiz, assignment, that sort of thing. I get an array of the various fields, all the various grades that I have. And by calling get field at 1, 2, 3, 4, I get the various fields. I will get get field 1, get field 2, get field 3, get field 4, get field 5, 6, 7, go down the line. So I'll get string for each of the fields, convert it to a number. So that's also a great question. So we'll get to that in a second. Let me finish off what I was going to say. Once I have all those grades, I make this dgrades data structure, which has all the data I need in it, and I just shove it into this return value, this grade set 1400. So I read off the line of text, pull off all the parts, put it into a structure, shove that structure into a bigger structure. So a box in a box. Why do we need the free data set? Why do we need the free data right here? Here's my malloc. Here's me calling free. Because I called malloc a bunch of times. I called malloc for each one of those lines, each one of those fields. I called malloc to get a dynamic array of data. If I have a dynamic array of data, it's my responsibility to give it back to the system. So free grade set. Where's free set? Okay, free grade data, free grade set. So here is my set of grades, all my grades. I go to each one of these grade types and free up the memory in that grade type. Free grade set, it's going to look very similar to this. I just have a pointer to the set of grades. I technically could have just, instead of using a pointer, I could have just not used a pointer. That would have been fine. But what I wanted to do is make sure that this thing is equal to null afterwards. I want to change the value to make sure I have nulls everywhere for my dynamic arrays. So every time I called malloc, I need to make sure. So think of it as an IOU. I watched Dumb and Dumber with my kids recently. Probably was inappropriate considering they're kids, but I watched Dumb and Dumber with them. The IOU scene with I don't know if anyone's seen it. They find a big batch of money, and they're living large, but they're putting IOUs for everything that they buy, and they essentially have a big briefcase full of IOUs. Every time you call malloc, you owe the system a call to free. So every time I call malloc, I have to call free whenever I'm done. And so this is me calling free for every one of those things. I go through each one of these data, like assignments, the quizzes, and each one of these has a dynamic array. It has the array of numbers that I've kept in there. So I need to go through this thing and free everything up. This will do the job, except for one little problem. What if I do this? It may not even break it, but it will break it and do something horrible, I think, in release build. Let's find out. Gonna blow up my face. Oh, I gotta do that array size thing. Well, it didn't blow up in my face. That's surprising. Let's do it as a release build and see if I can blow it in my face. It may have improved C++ since then. Still not a good thing to do. Well, it did not blow up in my face. That's really disappointing. If I free this, what should A grades be? It'll be null. If I try and free null, what happens? Well, it used to blow up in my face. If you try and free the null pointer, there's nothing to free. There's a null pointer. What I should have is maybe checking to see if it's equal to null before I try to free it. That would be the one little, I'm just going to give it the answer on that one. I should check to see if A grades is equal to null. If A grades is equal to null, don't free it. If it's not equal to null, free it. Just good habit. All right. Can I unpack anything else? I know this is a lot to take in, but we have this data structure that stores all of our grade data. we read in line by line, make one of these D grades types, shove it in this giant data structure. Then later on, I have a way of calculating that. Oh, wait, how do I know how to calculate like the assignment grade? Well, I have a bunch of grades. I have how many I'm keeping. I have how many I'm throwing away, or how many I'm keeping, the size of the array. I'm trying to get the top n average, aren't I? Wait, don't I have that from top n average from assignment 6? Here's an array of numbers. Here's the number of grades I have. Here's the number of grades I'm keeping. If I have those numbers, I could just call this function and calculate the averages. So maybe it gives me 80% on the assignments. And then if the assignments are worth 30%, if I multiply it by 0.3, what do I get? I get how many points I should have for the assignment grades. Okay, we're already way too long, and I don't want to hold people up more than already, but is that hopefully making some sense? A lot of this is just plugging away and practicing and also doing little bits at a time. But some people were doing that and then getting like compile errors or syntax errors and getting frustrated with that. And I completely understand and get on board with that because it's frustrating. Okay. If not, what I'm going to do, I'm going to stop sharing. I'm going to stop now, and I'm going to post this online soon-ish for other people to have a look at. Again, the big thing is to make sure you get some practice with malloc, but then also try your best with this and see how far you can get, because this will actually review a lot of the different parts that we're doing with the assignment, or with the class so far. It covers for loops, it covers structs, it covers and also conditionals, it covers pointers, it covers dynamic arrays, it covers static arrays, it covers all sorts of things. So what part of reading files were you? Reading files is I open the file, I'll get line. Where's my file? I have a file here, a pointer to a file, actually, a file structure. I call open, I open the file, reading it, and I'm going to, so here's the name of the file, here's the file structure I'm going to make. I'll fgetS for each line until it returns null. So I read in each line of the file, put it, and I'll be putting it into a character array, if you will. And then after I'm done, I close it. Open, read on lines, close it. 3-step. I don't want to redo the whole thing because I already did 20 minutes on that one, but you can rewatch the video on that part as well if that's not clear enough. All right. All right. Thanks, everyone. I'll hopefully post this soon. All right. Thanks.